Hi everyone, this video is to help you learn how to write equations of trig functions if you're given information about the function. The information could be given either in written form or on a graph. Here we go. These are the two forms of what we call a sinusoid that you'll want to remember. This would be the one that I usually start with, but this is the one that you'll probably see. The one on the left you'll probably see more often, like in a textbook or on Math Excel. These are called sinusoids, but because we're making something that looks like a sine graph, but keep in mind that also could look like a cosine graph, so you're allowed to use cosine as well. For this one, it says, write an equation of a sinusoid that has the following characteristics. So it has an amplitude of 3, a phase shift of pi over 6, so this would be c over b. And then we have to figure out the actual b value based upon the period being pi over 2. So let me remind you that the period of a sine graph is 2 pi, and we find it sometimes, like when it changes, we find it by dividing by the b value. That looks terrible, sorry. We can also then solve for b and say if we want to find b, we take 2 pi and divide by the period. So if I were to say b is equal to 2 pi over 2, we get the b value of this situation to be 4. So then we write this out as y equals 3 times sine of b is 4. I'm going to write it in factored version to start off with. Pi over 6. There's no shift up or down, so there's no d. And you can just leave it like that if you prefer, or you could multiply the 4 in and you get 3 sine 4 of x minus 2 pi over 3. Okay. You could also, it didn't say anything else in particular, you could make it be a cosine graph. Nothing changes besides the cosine. It makes it look a little bit different. It didn't say it had to be sine. It does say sinusoid, but this was something that would be fairly similar. You could have also made this be a negative in front of the sign as well. All right, here's our first graphing problem. I hope you're going to be able to read the points. So you want to pick which graph you're looking at. So do you want to do sine? Do you want to do cosine? And where do you want to start? When I look at this, I see a cosine. Sorry, that's definitely sine. I see a sine curve right here. This is what I see. And I see that this first point starts at pi over 6, comma 5. And then this last point, so one cycle of the graph, is at 7 pi over 6, comma 5, which tells me that the period of the graph is 6 pi over 6, which is pi, which then I use the fact that b is 2 pi over the period, so 2 pi over pi, which gives me 2. So I've got one value for my equation already. Then I need to find the amplitude and the shift up or down, because clearly that has occurred as well. So I usually do the shift up and down first by looking for the lowest value and the highest value and finding the midpoint of those. So the lowest value occurs at 8. Sorry, the highest value occurs at 8. Oh my gosh, the lowest value occurs at 2. Divide by 2 to find the middle. 10 divided by 2 is 5. That is the shift up. That's your d value. So we went up 5. Once I've figured out the midline, which you can see it right there in the graph, that's also where the sine curve is starting at. Then you can find the amplitude by just subtracting the top value from the midline. So the top value is 8, the midline is 5. 8 minus 5 equals 3. This is your amplitude. And then finally, you want to figure out your shift. Well, I said I was starting at that point, so that's clearly to the right pi over 6. So we are going to write down right pi over 6. and write it in that factored out form first. So this will be y equals 3 sine of 2 times x minus pi over 6 plus 5. And then if you prefer, then you can just multiply the 2 into the equation to get that one over here. Now, if you had wanted, you could have done this as a cosine graph and started at that point. This would have been an upside down cosine, so a negative cosine. So what would change is it'd be a negative 3 instead of positive. The b stays the same. And notice that we went to the left. That's a pi over 12 actually there. But otherwise, nothing else changed. So you would just write it just like that. All right, next one. This one, I didn't put points on there for you, sorry. But I do notice when I look at this that this looks like an upside down cosine that's starting on the y-axis. So when that happens, I really like to make a cosine curve out of it. So here is my starting point. And then from 0 to 2, I actually have half of a period. So half of the period is equal to 2, which means the whole entire period is equal to 4, which means when I go to find the b value, it'll be 2 pi over 4, which is pi over 2. Okay, so I have b. There is no shift right or left, so nothing else is going to change inside with the x. But I do need to find my midline, which you might be able to tell by looking at it. It's at -1, but maybe that's too tricky. So then you just take the midpoint of the top value. So this is at 2, 3, and this is 0, -5. -5 plus 2 divided by 2. Well, -5 plus 3, sorry, is -1. That is your shift up or the d value. And then you just count or subtract to find the amplitude. So the amplitude is equal to 4. You write it out. Y equals, this is upside down cosine, right? -4 cosine of pi over 2x plus, I guess, -1. Guess I didn't have to write it out. I could have just erased it. Next one. So this one is either a secant or a cosecant graph. So it's going to depend on how you see it, on if you can, what you pick. I think I'm actually going to use the line tool here. So it appears to me that the midline is right here at 2. And then this would be the highest point. This would be the middle of the graph, and then the low point here, and then back crossing just like that. So this is, you want to think about like, is it a sine or a cosine curve? Ooh, and I should have made this graph maybe a little bit bigger so you can see what's going on. Maybe I will kind of graph it and stretch it out so you can see it. Like, give me more space to draw it. Hold on a second. The joys of the smartboard. Okay. It's a little bit better, not great, but good enough. So this would be the low point of the sine curve. Then this is the point on the midline, and here's the high point of it. So it goes like this. All you're really trying to do is figure out the equation of the sine or the cosine that you have, and then rewrite it as secant or cosecant. So I definitely see this as sine because it is, I see a point on the y-axis that is on our midline. Okay, and you can see that the midline is at 2. So that's our shift up, 2, which is our d value. And then there's clearly a shrink in the graph. This is a little bit harder to tell because I stretched it all out, but this is 2.5 So 5 halves, and this is 1.5, so 3 halves. So that means that the amplitude would be the distance from 2 to 2.5. So the amplitude is a half. And then the period of the graph then, it looks like, if you look at it here, I don't even have to count it. I can see that I went from negative pi to 0 is half of a cycle, and then to pi is another half. So the period is a normal 2 pi. And if I were to write this as just a sine curve, it would be 1/2 of sine of, let's see, x plus 2, which means when I write it as its reciprocal function, that would be 1/2 cosecant of x plus 2. Boy, let's make sure I did that right. There we are. Okay, last one. Yep, it's tangent graph. And I hope you can see that there are vertical asymptotes at negative pi over 4 and 3 pi over 4. And it is also flipped. So you could think of it as cotangent as well, but because it's so close to the origin, it's leading me to believe that this is a tangent graph that's been flipped. So that's the way I'm going to do it, but it could be a cotangent as well. Okay, so my normal tangent, first of all, has a period of pi, something that students tend to forget. So when I look at this, I can figure out the period by just looking at the vertical asymptotes. So it goes from negative pi over 4 to 3 pi over 4. That's a distance of pi. So that means the value inside with the tangent didn't change at all. It's going to be a 1 because it's got the same period as normal. But it did shift to the right. So we are going to move it to the right pi over 4. And it clearly shifted up and also has an amplitude or a stretch, really. It's not really called an amplitude with tangent. It's just called a vertical stretch. So you can see the vertical stretch here from, like, this would be your main point normal, like your 0, 0 point that's been shifted over and up. And you can see here is the vertical stretch of 2. So that means the value that's going to go out front of my tangent curve is going to be 2. There was no period change, but we are shifting to the right pi over 4, and we also went up 1. This point right here tells you went up 1. Okay. There will be lots of different activities that you can do to help you practice both graphing and writing equations, so make sure you take advantage of them if you're struggling.